Hello, guys. Today I'm going to talk about the objective of the course that you have taken this semester. The course is Formation Evaluation and Petroleum Engineering, and the course focuses on some methods that are used in oil and gas exploration. In addition, in the second module of the course, Petroleum Engineering, you're going to learn some terminologies that are used by petroleum engineers in order to improve production from hydrocarbon reservoirs. In order to better explain the objective, I've prepared a PowerPoint presentation. Let's go through it. So now look at the world map. If you look at the map, you're going to see some red area. A red area corresponds to those areas with major oil and gas reservoirs. If you look at this map, the first thing that you may notice, oil and gas are found in specific areas in the globe. So, for example, if you go to the middle of Africa and drill some wells, definitely it is very low likelihood that you're going to find some oil and gas. In other words, there should be some important criteria, geological criteria, so that we can say that area should have some oil and gas reservoirs. Like, look at the US map. Major oil and gas reservoirs are located in Texas and Gulf of Mexico. It doesn't mean that, for example, in California, we don't have any oil and gas. We have, but those oil and gas reservoirs are not significant compared to Texas. Okay, so that's the first thing that we should notice. Now, what should we do in order to find oil and gas? Definitely, as I mentioned, there should be some important geological criteria. And for that reason, we have to do some geological studies. We have to study the rocks. We have to study the formation, every geological layer beneath the surface. So we have to study these things. And for that, to study these things, one thing that we can do here, we may go to the field and just look at outcropping formations, collecting rock samples, looking at the exposed rocks. And also, we may drill some wells and then take some core samples from the well and then analyze the cores in the lab and then getting more information about subsurface geology. Okay. In addition, we may, give these these samples to geochemist in order to analyze the chemistry of those samples to better understand, the chemistry and the composition, in particular in terms of organic composition of those rocks. In addition, we may conduct some geophysical studies. The reason why we conduct geophysical studies because we have some limitations in terms of geology. Okay, so for example, for geological study, we have to drill some wells. Sometimes it is expensive to drill more wells. Okay, sometimes in a specific area we may not have any permission for drilling a well. So assume that there is a property and this is like private property and the owner doesn't allow us drilling a well. And so for these reasons, we may conduct geophysical studies. That geophysics is indeed indirect observation of subsurface through physical laws. There are different methods of geophysics. For example, one method of geophysics uses gravity or gravimetry. It is called in the terminology. So how this method works? We have a device that measures the gravity field of the Earth with high resolution, with high precision, and then what we do, we measure the gravity field at different locations, and by analyzing the gravity field, we are able to have some idea about subsurface. The other method that we may use in geophysics is magnetometry method. Indeed, we measure the magnetic field of the Earth. And again, this method is very interesting because, for example, if the subsurface layers have some, for example, iron composition, they may affect the magnetic field of the Earth, and using that, we are able to identify the geology. Or we may measure the electrical resistivity of subsurface. And but the most important method for oil and gas exploration is the seismic method. So in seismic method, we produce some acoustic waves, and those acoustic waves travel down through the Earth. And by analyzing those waves, we are able to have some detailed image of subsurface. For example, what you see here is an image of an alkaline that has been obtained using seismic method. In other words, seismic method enable us to image subsurface with a lot of details, and those details are very critical in order to study subsurface. So here it shows, what we do. So definitely when we want to find oil and gas, what we have to do first, we have to do some geological study, geochemical study, and also geophysical study. Within the realm of geophysics, we go with seismic mostly, but it is possible that sometimes we may use gravimetry. Mostly, I'm talking about oil and gas. Okay, for oil and gas, mostly we use seismic, but in some scenarios, we may use gravimetry or magnetometry. And then one of the most important things that we do is drilling a well. Because by drilling a well and measuring different properties of rock, again, we can improve our understanding of subsurface. And indeed, this is termed as formation evaluation. Okay, so as I mentioned, one of the most critical steps when we want to find oil and gas is by drilling a well. And by drilling a well, we are able to study different geological layers, even take some fluids from different geological layers. We are able to identify oil-saturated zones. We are able to estimate porosity. We are able to estimate permeable layers, impermeable layers. We are able to estimate hydrocarbon resolution. And even using new tools such as nuclear magnetic resonance, we are able to estimate permeability of the rocks. So with well logging methods, we are able to obtain so many pieces of information from subsurface. So what is well logging? So as you see here, well logging is indeed, it means that we send some sensors down to the borehole, and using those sensors, we are able to measure different properties of the rocks. So how does it work? These sensors are called sonde, S-O-N-D-E. So how it works, once we drill a well and then we send these sensors down to the bottom of the borehole by using a cable, and then gradually bring up the sonde to the surface. At the same time, sonde measures different physical or petrophysical properties of rocks. For example, we may have a sonde that measures the gamma ray emission from the rock. We may have the sonde that measures the resistivity of the rocks, and etc. So one of the most important things that we should know is that using this data that's called well logging data, we are able to obtain a detailed information about subsurface. As I mentioned, for example, we are able to identify permeable layer from impermeable layer. And within permeable layer, we are able to characterize the fluid. And also, we may be able to obtain some idea about the porosity of the reservoir, the permeability of the reservoir, about the oil saturation in the reservoir. And also, we may be able to have some idea about the volume of the oil that we can produce from a reservoir. Just let me explain this point better. Okay, guys. So what you see here I'm going to show you how, for example, by putting together two different pieces of data, we are able to interpret subsurface. So one of the logging tools that you're going to learn in this course is gamma ray tool. And indeed, gamma ray 2 measures the gamma ray emission from the rocks. So here is the thing. Usually shale formation produce a lot of gamma rays compared to like sand formation, sandstone formation, or limestone formation. So as a result, whenever the gamma ray reading is very high, like close to 100, we may say that, okay, this is a shale formation. And you know that the shale is not permeable. So is indeed shale is an impermeable layer. So look at this example. So here you see two zones with relatively very high gamma ray reading, close to 100. So these zones, like let me just mark it here, this zone, I mean, this zone and this zone. That has very high gamma ray, we may interpret it as shale formations. And then here we see a zone with low gamma ray that, for example, if we have some prior information from geology, we may identify it as a permeable layer, and based on our geological data or litho-density data, we may say that, okay, this is a sandstone formation. Okay. So as you see now, using a gamma ray tool, we have been able to identify shale layers and also sandstone layer. Now, as I said, the major goal of this entire procedure is to find hydrocarbon reservoirs, oil and gas reservoirs. And not only we want to identify oil and gas reservoirs, but also we want to quantify it. How much oil and gas we have in the reservoir? What is the porosity of the reservoir? What is the oil saturation in the reservoir? How much of the oil we can produce? Okay. So that's the reason we use other well logging tools. For example, one of the well logging tools that we use is resistivity. We know that oil is not conductive. Okay. So as a result, on the other hand, brine, for example, is conductive. And we know that when we go deep, like 2 kilometers or 3 kilometers below the surface, the water in subsurface layers are brine and it's conductive. So now consider a layer that is saturated only by brine and consider another layer that is saturated by oil. It is very easy to say that, okay, if the layer is saturated by oil, it should have a higher resistivity and lower conductivity because oil is not conductive. Okay, now let's go here. So what you see here, this log shows the resistivity. As you see, it shows that resistivity, for example, varies from 0.2 to about 20. 20 is very high resistivity, 0.2 is low resistivity. So here we see a low resistivity zone that corresponds to the shale layer. Usually shale layers show very low resistivity. And then here within our sandstone layer, we see two distinct zones. One zone that is at the bottom has extremely low resistivity, like about 0.2. And then the other zone that is here has very, very high resistivity, kilos 20 ohm meter. So what we can say that because this zone, so just notice that this is one layer, okay? So within one layer, we see two different zones. The above, at the top of the layer, what we see high resistivity zone that can be interpreted as hydrocarbon saturated zone or oil saturated zone or gas saturated zone. So that depends on what kind of hydrocarbon we have. And at the bottom of the layer, what we have brine. So we have low resistivity zone and we can interpret it as brine. And this is how we are able to interpret different geological layers. So what I'm saying that the logging data can provide us with a lot of pieces of information that are so critical for oil and gas companies in order to invest on some area to have some oil and gas production. Okay. And in order to do so, definitely they have to go through a lot of evaluation. You have to study subsurface. And one of the most critical part of this this sort of evaluation is well logging. So we put different logging data together in order to have some idea about subsurface. So here is the question: what can we get from well logging? We can get very critical information about subsurface using well logging data. The first thing, we can identify this permeable from impermeable layers. That's the first thing that we can get. The second thing, we can identify hydrocarbon saturated zones. And then we can have some estimates of porosity, permeability, and also we can have some estimate of hydrocarbon saturation. And then we may have some rough estimates of the producible hydrocarbon in the reservoir. So just let me explain the sixth one. So we are not able, practically, we are not able to produce all the hydrocarbon within the reservoir. Usually, we are able to produce a fraction of the hydrocarbon from the reservoir, for example, 10%, 20%, 50%, and etc. And this is called recovery factor. Okay, so that depends on the reservoir and the pressure of the reservoir and driving mechanism in a reservoir. Depending on all of these things, we may produce like from 5% to up to 70% of the oil and gas in the reservoir. And well logging uh, data may help us to have some estimate, rough estimate about the recovery factor as well. So as I mentioned, all of these pieces of information are so critical, and it helps the company to make their decision whether or not they should focus on some specific area for oil and gas or not, whether or not they should invest or not. So assume that the company, after looking at different data that they have, they come to conclusion that, okay, this is a good area to invest. We can drill several wells here and produce oil and gas. And if we do that, we may be able to make a lot of money. So in other words, that area is highly profitable. So now assume that the company comes to the conclusion that, okay, this is a good area to invest. And then the next question that the company has to answer is, what is the best strategy for an optimum production? So what I mentioned in the previous slide, I said that we are not able to produce 100% of the oil in the reservoir. We are able to produce a percentage of the oil in the reservoir that is called recovery factor. So the higher recovery factor, the better for the company because they can make more money. And in order to reach the optimal recovery factor, they have to make some specific strategies during production. And indeed, this is where this is the time that petroleum engineers step in, and just by looking at different data that they have, in particular during the production, they design the best possible strategies in order to obtain the best possible production from a hydrocarbon reservoir. Okay, so this is what I mentioned in previous slide and summary. So note, not all hydrocarbon in a reservoir is producible. Depending on the reservoir condition, reservoir pressure, driving regime, permeability, and etc., we may be able to produce like from 5% to 70% of hydrocarbon in the reservoir. And what the reservoir engineers do is that they plan the best strategies to reach the optimum production from a reservoir. Okay, so what you're going to learn is this in this course. In this course, you're going to become familiar with several and important well logging tools that are used in oil and gas industry. you're able to interpret their data, put all of them together to have a better interpretation of different geological layers and have some accurate evaluation from different layers. As I mentioned, we have a second module. The course has two modules. So the first module is the formation evaluation, in which you're going to learn about different logging tools. And the second module of the course is indeed petroleum engineering, in which you're going to learn some terminologies that are used by petroleum engineers and how they try to optimize oil and gas production uh, from a reservoir. And then also we have a lab session. And in the lab session, we're going to work with some real logging data and also production data. In other words, they're going to somehow combine the information that you're going to learn in the first and second module of the course. You combine them together to have a better evaluation from a real reservoir. So in other words, in the lab section, you're going to apply what you learn in the course to a real world example. So here is what you're going to learn in this course. The first thing you're going to learn is spontaneous potential log or SP log, that is used to identify permeable from impermeable layer. Then you're going to learn about gamma ray log. Again, it's used for identify permeable layers. Then the third logging tool that you're going to learn is electrical resistivity log, that is used to identify hydrocarbon saturated zones, and also you're able to estimate water saturation in the formation using this logging tool. And then from logging water saturation, you're able to estimate hydrocarbon saturation. Then you're going to learn neutron porosity log, that is used to estimate porosity, density log, that is used to estimate density and also porosity, sonic log, that is used to estimate seismic velocity and porosity. And finally, you're going to learn about NMR, nuclear magnetic resonance, which is a more advanced logging tool that almost you're able to estimate all of these parameters that I mentioned above: porosity, permeability, and more. And so it's a very fascinating logging tool. And I hope that you're going to enjoy this course, and you will be happy at the end of the semester that you have taken this course. And I'm very confident about that. You're going to enjoy the course a lot. So if you have any question about the course, I will be happy to answer your questions. Thank you.